The findings were very much expected from us and somewhat alarming in that we only replicated about 28% of the studies that we attempted to do. You might ask, is there reason to be concerned? And the answer is definitely yes. I think we should all be concerned, not just the scientists on my side of the fence, but also the consumers on the other side. We would have strong concerns over the nutrition area of research. One, because there's a lot of invested interests, a lot of funding in.
Hi, Joe. Thank you for finding the time to speak to me today, even though it was relatively short notice from my end. I'm really looking forward to talking about your scientific work, replication, and your academic work. But before we get deep into the topic, could you please introduce yourself? I want to know a bit about your athletic history, but also now your ultra races, and then maybe after we can get on the academic side.
Okay, yeah, thanks, Nikki. Thanks for having me. So, yeah, first athletics. I've been running since I was 12, actually, and most of my career has been in track and field. So, mostly 800 meters, and then towards the latter end, I moved up to 1500s, up to about the age of 32, 33 would be when I would stop taking it as seriously maybe as I've done. It was definitely primary focus for most of my life. So, I would have won Irish senior championships and gone on a couple of international trips and have a number of caps to my name. I never really broke onto the big international scene, but certainly
Right.
as a national level athlete, I wasn't too bad. But I did grow up in the mountains in West Cork and would spend a lot of time training and running the hills. And aside from my athletic career, I would have spent a lot of time in adventure sports. So actually, growing up, my dad was working in outdoor pursuits, and we would have spent a lot of time climbing, mountaineering, caving. So I kind of always knew that I would want to move eventually, kind of to mix my running aspirations with in the mountains. And so trail running was kind of natural progression for me. So around 32, 33, kind of took a break, went traveling for a while, and then really found a love for trail and ultra trail running. Started in Ireland, around an 80K in Ireland. I was fortunate to win that one, kind of first time out, which was, as I say, it was the worst thing that ever happened to me, because then I thought, oh, maybe I could be good at this. Um, Even though I said afterwards, I will never, ever do this again. I was in a pretty bad way. Coming from track, it's a very, very different discipline as,
Mhm.
in particular, the muscle conditioning and the mentality of ultra trail was a big shock to the system. But now I'm at it, 4 or 5 years. And yeah, kind of hopefully rising a little bit through the ranks. I've had 3 or 4 top 10 finishes in UTMB World Series races, and still the plan. I was in UTMB, the big 175K 2 years ago. Unfortunately, DNF'd because of heat issues, and so all plans going ahead. I will get back there for September and complete the lap.
Nice. And any time aspirations or finishing the
Not for
lap
this
and
one.
enjoying it?
Normally, I'm very competitive in everything, including the ultra trail stuff. But I think for a 100 mile, and particularly one like this with this much elevation and most of it at altitude, I've always said, I mean, this is a race I want to do my whole life, and so I'm just there to participate. I'm setting aside all of my competitiveness at the start line and just getting around. So it's going to, if I get around, it's going to be something like 28, 30, 32 hours. I imagine it could be slower, could be faster, but certainly nothing rapid, and I won't be trying to be competitive. Um, as far as my academics, then I was an undergraduate student in sports science here in Dublin, and then went directly into a PhD in footwear. Actually, so a big part of my
Interesting.
research and focus was on minimalist shoes, and how effective or indeed worthwhile a transition into minimalism or barefoot running might be. It was around the big time, the trends of barefoot and minimalist running, so I jumped on that bandwagon for sure. Um, and then I went into academia. I've been working in academia for about 12 years, following on from that. And pretty early on, I got teaching research methods, kind of one of those subjects not many people want to teach. I find it's a bit of a black sheep of the of the sports science academic circles. And I found myself really enjoying it, and getting a lot of return from teaching a very difficult subject to people who typically wouldn't be that interested in it. But over the course of that 10 years, I started to get increasingly concerned that what I was reading as far as best practice and research methods textbooks, and some publications that particularly started coming out from psychology, that a lot of these alarm bells were ringing, that maybe a lot of what we were doing was definitely suboptimal. But no one was really looking at it in sports science. And so this triggered a big change, a shift for me. I moved away from any original research in footwear or indeed any other kind of I did some work in strength and conditioning and some other small areas too. Um, to start looking more at meta science, so looking at the bigger picture of how we're doing science in sports science, largely triggered from some of the reports in psychology, for example, that I demonstrated that they had a replication crisis, so that's what they called it at least, where actually a lot of the findings that they were claiming were not reproducible when someone tried to recreate the study itself. So we decided very ambitiously that we were going to try and recreate what they'd done in psychology, but here in sports science, but with a very small team. We were just 3 at the time. And so we conducted the first large scale replication project. And as aside from that, we would have done a lot of other meta science work and a number of publications investigating science, which I guess is, leads us full circle, which is why we're here today, Nikki. I guess we're here to talk about some of that work.
Exactly. Yeah, yeah. I mean, I can attest to the fact that students don't want to learn the research methods. I mean, my formal education is more in computer science, but we also had that unit. And when I was writing, like my latest article in my blog was also on this topic, essentially to also do the prep for this. And I also had to re-rack my brains around like, what does statistical significance mean? What does the effect mean? And for me also, who kind of reads a few scientific papers also for my publication, I also needed to make sure that I know my definitions quite well. So before we dive deep maybe on the replication side, can you give a bit of an idea of like how is a study conducted? Like what are the steps and what are the challenges there to even create a normal study, a basic study, maybe to do heat adaptation and or to not do, or like what are the benefits of heat adaptation? Maybe we can use that as an example.
Sorry, ask that last bit again. What are the benefits of what?
So, for example, if we can use an example, it's like heat adaptation, right? We were talking about UTMB and that you struggled with heat. Let's say you wanted to investigate that. How would you go around creating that study to understand what are the benefits or what is the best way to get heat adapted?
Yeah, so look, a great quote for what academic process would be is it's a process or an act of disciplined curiosity. So you're trying to
Yeah.
eliminate bias and investigate theories or problems using something called the hypothetical deductive model of reasoning. So very early on, even as early as the 16 or even 1500s, people recognized that humans aren't actually very good at making unbiased opinions based on what they're observing, and a lot of early science was very much observational. And so the more modern approach to scientific exploration would be using some form of statistical analysis, and that tries to eliminate that process. So in the case of a heat adaptation study, you might have a theory or a concept that you want to investigate. Can an athlete adapt to the heat demands of UTMB or a number of athletes? So there's your problem or your theory. And so you would design a study, most frequently use something called a null hypothesis significance test. And that follows a pretty established scientific method where you would first define clearly what is my research question. Is there any benefit of doing heat training leading into a hot race, for example? You would then examine the literature and come up with a methodology that you can very vigorously test this theory, and you're testing against the null hypothesis. So essentially, what you want to do is design a study in such a way that if there is any element of truth to this observation or this theory that you're testing, that it should be able to be separated just from noise. And you should almost be surprised that, wow, there is definitely something here that is not the null. That is, there is definitely some trend emerging from this data. And so once you've designed this study rigorously, you then collect your data. Typically in our work, of course, it's very much human trials. So we recruit humans in and we do a number of interventions or any number of different ways that we can manipulate the study intervention to examine the outcome. And then once we've collected this data, we run some statistical analysis and we make a claim. And the claim is either that the data is not any different than the null, that we haven't found any observation here that would lead us to suspect that you can adapt to heat, or that the claim is one that you find evidence against the null, that you say the data in this study doesn't support the null, and therefore there may well be an advantage of heat acclimation for running something like UTMB. And the way that I've defined that is actually very important, that I haven't made a statement of fact or fiction here. This is not proof of an observation. I didn't say we have found evidence or we have proven that heat acclimation can help you run something like UTMB. And science was actually never meant to be used like this. One of the concerns, of course, in modern social media times is that we very much like short headlines or bullet point outcomes, or something that can fit in a tweet. And so people like to make these very clear, very definitive claims about the research that they're doing. But really, at the very most, that what you can do is say, on the basis of probability, assuming all other things are upheld to a certain level of rigor, we may tentatively be able to suggest that there is something here, but we are awaiting a lot more evidence. And that's really the most that you can say from a scientific study. Now, that doesn't really fit, again, with what people like to see or do today, because unfortunately, the modern climate of academia is that you need to get published in order to get academic tenure, or for personal gain, or even for financial benefits at the end of the year. And the most likely way that journals are likely to publish work, something called significance or publication bias, is to find something novel or alarming, or make a very pronounced claim about what you've done in your study. So on one hand, that kind of sells, the sexy clickbait really sells, but on the other hand, science isn't really designed to be treated like that. And it's both a danger of the way that we're consuming it online, and also people reading research papers. And it means that we've kind of lost a little bit of the nuance of how scientists should conduct themselves, I think, along the way.
Did I understand correctly that kind of the mental framework going into a study should be that you don't expect that the hypothesis is true, or rather that the evidence needs to be almost so substantial that we are absolutely sure that it overwhelms the noise, right? Like, or like, yeah, is the mindset that we will not find anything, or should the mindset be we want to find this? Can you maybe comment on that?
But yeah, your point is absolutely right. That really what should be asking, when you make a claim, when you make an observation in the research, you should be asking, what is the level of fragility here? Like, how likely in the long run is this observation to reoccur? And that forms the foundation of replication, really. That's why replication is a cornerstone of science, because unless you can repeatedly observe the same phenomenon again and again and again, we cannot make any claim about the theory that we're testing, to make any binary claim. So really, you're trying to say, is this possibly as a result of an alternative explanation? Or can we be very, very sure that the claim that we're making is a true one? So that's definitely the way that I would encourage people to think about the way that they make claims in research. Yeah.
And you just said we need to be very, very sure that the claims we are making are a true one. What things can you adopt? So what are the qualities which makes a high quality study, or which makes the researchers very, very sure that the claim that they are making is true?
It's a great question. It's a really difficult one to answer, because on the surface level, people would love to be able to read a paper and then to evaluate whether this study has high or low quality. But unfortunately, it's a lot more difficult than just reading a study at face value. But at face value, there are a number of things that we can look at to determine, in today's current climate, whether we might consider a study of a higher or lower quality. This might be transparency, the use of cautionary language, so someone not avoiding making very clear or binary claims, but instead suggesting, well, at least we might cautiously accept this theory, but we are awaiting additional information, etc. And of course, that a study is written in such a level of detail that it is reproducible, that somebody could copy the study methods very, very clearly because they've been written very well. And in addition to that, things like sharing raw data would be really valuable in all of the analysis and syntax, as well as some adequate control of error, because we've said that really, when you make a claim in research, for it to be a high level claim, you have to consider any possible alternative explanations. And two of the most frequent ones are what we call type 1 and type 2 errors. So if you've made a claim that is statistically significant, yes, if you take 12 athletes and give them heat acclimation in a sauna, they are more likely to run better at UTMB than 12 athletes who didn't have heat acclimation, at a level of significance of p less than 0.05. So if I say that this claim is statistically significant, I could be right. We don't know this. It's just the claim that we've made. But I could be making a type 1 error. I could be accidentally suggesting that there is a benefit of sauna for heat acclimation. But in reality, our data actually in the long run doesn't support this theory. And the only way we could know this is by reproducing this or replicating this study again and again. And I say, so that's kind of face level checks. We can evaluate a study looking at for these things, whether it's present in the study. But unfortunately, a lot of the major concerns around reporting standards happens under the hood, so to speak. And the best analogy for this is if you imagine going and buying a used car in a garage. So if you went into a car garage and you were buying a secondhand car, the salesman would have this car buffed beyond belief. It would be spotless. They'd have buffed the inside and outside. They would have cleaned out the engine bay, made it look like it's an immaculate car, and they'll sell it to you and say, oh, we've given it a full service history. We've inspected the engine. It looks incredible. And these are very much face value checks. You have to just take what they're saying at face value. You don't know whether this car actually is very close to falling apart, or maybe a former owner was a rally driver, and there's a huge amount of issues. And so relating this to research, it is very possible for a study to presented it in its end state, very polished. So like polishing a turd, you can have all of these arbitrary degrees of freedom or decisions that lead up to you saying, by the way, here's our study and this is what we intended to do all along. But you don't know all of these decisions that have taken place that are not disclosed within that paper. And so ultimately, it's very, very difficult for me to give an answer to say that when someone's reading a study, whether you can evaluate high or low quality. They only really know we only really know in the long run is via replication. So it's that study or that theory has been repeated a number of times, or in very highly designed or well-designed meta-analysis, for example. So using more meta-science practices to culminate lots of evidence together. But my golden rule is no one study is proof of anything. And so even if a study appears to be very highly detailed and very well written and of high methodological quality, it doesn't necessarily mean that the claim is therefore more robust.
Right. Okay. So of course we've mentioned a lot like on the replication side, and I think you outlined why it is necessary. For me, the kind of interesting thing is that no one single study is a proof of anything, right? And the way to maybe move towards a proof, to use the terminology, is, as you said, through replication. And you established the Sports Science Replication Center. Can you maybe give us a bit more information, like why did you decide that you needed to start this replication center, and maybe how did it start? What are the few things that you started working on?
Yes, so I've already mentioned that largely the inspiration for this would have come from some of the work in psychology, and in particular, there was a couple of larger publications which really led me to start really questioning what we were doing in sports science. A lot of the issues that we were seeing in questionable research practices, like publication bias and p hacking and very small sample sizes in particular, were things that were very evident in sports and exercise science and not just in psychology. And when I mapped the two across, I realized that actually a lot of the concerns that they were making there were very true here. And so that was really the inciting point for wanting to look at this. And so we would have put together, as I said, a very ambitious proposal for funding for two PhD students to launch this replication center, and both were successful. So the process was very much that we first needed to gauge whether there was any interest in conducting replication within sports and exercise science, because even still now, this was 5 years ago now, but we are somewhat immature, I would say, to these more meta science approaches or philosophical approaches to the meaning of science. And so I was pretty convinced actually that we wouldn't get much interest from other scientists in the area, because being such a small team, part of the way that we intended to run these replications was to recruit collaborators, people who would just voluntarily agree to be randomly allocated a study from a pool that we would randomly put together, and then they would have to replicate the study. And so we wanted to kind of build on methods that were being somewhat criticized in psychology, because they were selecting studies that, on the basis that they thought maybe these should be replicated or maybe would not be replicated. So we wanted to do this in a slightly more of a randomized and unbiased fashion. And so the whole study lived or died on the ability to find people who would voluntarily run these studies for us. And we were blessed, really. We had initially a lot of interest. Probably it was just the tipping point. I think the timing was really good. That it was just around the time that people were getting very, very conscious of these issues in our discipline, as a result of some of the noise being made in many of the other social sciences. And so I have to, thank all these collaborators and people who got involved in this very large and ambitious project. And the replication was run by Dr. Jenny Murphy, who was the PhD student there at the time, and she was able to coordinate all of these people coming together. But essentially, to describe the project, what we would do is randomly allocate a study to a collaborator under their area of expertise. So if they said, I work in biomechanics or physiology or nutrition, we would have a pool of studies within that subdiscipline, and we would identify with each of these collaborators what access to facilities they had. So if they had a biomechanics lab or motion analysis or blood marker analysis or any number of different technologies. And from the available resources of the collaborator and from the pool of available studies that we had screened, we would then randomly allocate them one that would fit their needs from that pool. And so essentially, 4 years later, long story short, we ended up collaborating with more than 100 different individual replicators, and we completed 25 replication studies, which is still a small number. We're not going to by any means say that this is a overwhelmingly representative sample size to say that we have a replication concern in sports science. So let's be clear about that. But the findings were very much expected from us and somewhat alarming in that we only replicated about 28% of the studies that we attempted to do. And so, again, it wasn't surprising for us because at this point we were 4 years into this project. And aside from the replication work, we were also doing a lot of other meta science analysis of the research practices in sports science. And pretty overwhelmingly throughout everything that we looked at, it was suboptimal by a long way. So we have major concerns pretty much around the entire scientific approach in sports and exercise science, right from the formulation of the clear hypothesis to the analysis to the claims and to the journals and the peer reviewers and the process in which is supposed to protect us from research that should not really be that high in falsification. So that's where we are. That's the major point, and the take-home message from our project so far is that, one, we have big concerns over sports and exercise science, and two, empirically, we have a very, very low rate of replication. In fact, one of the worst in the social sciences so far. And that should be concerning for everybody, not just scientists that listen to this, but also, in a more practical sense, because I know that's your focus here, Nikki. But for athletes and coaches, this becomes really problematic in that if the vast majority of research that we're consuming as coaches and athletes is not replicable, in other words, the claims may not be something that can reoccur and therefore may not be true, how on earth do we start using evidence-based practice to guide our coaching? It's very difficult.
Yeah, I mean, for me, it's interesting that you say we managed to replicate 28%, and it feels like you expected such a number. And like for me, it's like, okay, we created, or over time, like this what feels like sometimes maybe overly complex system through peer reviews, through you know journal like tiered journals, high quality journals, and from my understanding, also you try to, bias is the wrong word here, but you try to choose studies which were had a higher chance of replication, right? Like, so recently published studies, higher quality papers and stuff like that, and yet we still had like 25% or 28% of them being replicated. Like, how, like, what do you say to the people who listen to this and I'm like, whoa, like, this is very low. Like, is this so bad? Is science so bad? Did the scientific community do so badly? Like, I don't know.
Yeah, it's a great, like, you might ask, is there reason to be concerned? And the answer is definitely yes. I think we should all be concerned, not just the scientists on my side of the fence, but also the consumers on the other side.
Exactly.
I would be very confident in saying that, unfortunately, the modern approach to science is become perverted by personal gain and overwhelming sources of bias throughout this process. In fact, we live in a climate which is called the publish or perish climate. So there are so many possible incentives and incentive structures invested in academia that it means that most of the time people are not doing science for the right reason, which is this very purist activity of learning more about the world. And unfortunately, it's become a currency for success, just like any other thing in society. Humans are humans. I give a lot of talks about these things, and I've got this great image of this massive pile of humans just like scrambling over one another to get to the top of the pile. And that
Yeah.
kind of is the way that, we're very industrious humans. We want to, if there's an opportunity of getting one up or getting higher up the food chain, we will typically take it. It's exactly why cheating exists in sport, right?
Yep.
When sport became more professional and there was more money available and more fame and fortune allocated within sport, people started taking more chances and therefore also taking performance enhancing drugs and cheating their way to the top. And academia is not immune to these same problems that the rest of society experiences. And so, unfortunately, as the currency becomes much more valuable, as you require publications for many aspects of the academic world, people now start to find more optimal ways of conducting research. Now, I'm not going to say by any means that this means that scientists are falsifying data, that they're making things up or taking dramatic shortcuts or something similar to taking performance enhancing drugs. I'm not saying that people are cheating the system necessarily. That definitely exists, but it represents a minority. But in fact, it's just that gradually over time, the course of research has become perverted to a point where they're very common practices, that things that we just accept, like the pursuit of very novel findings. People don't perceive that they've actually done something very credible as a scientist unless they've found something really novel, something new or undiscovered. Now, that's becoming harder and harder to do, of course, as science progresses and more people do science. But it also kind of evades the fact that science is about falsification. It's not about finding something new, but it's about uncovering the truth of the world. And so that means that demonstrating that something doesn't work is just as valuable as finding a novel, significant finding. In fact, if not more in many cases, because we don't necessarily want people to be engaging in practices that are not true or effective. But because of this preference towards novelty and significance and a bias towards sexy findings and clickbait, essentially, is what research has become. People are now prioritizing and publishing almost exclusively only stuff that finds these significant novel things. And that means that the research is now skewed towards what we call false positives. All of these findings which say, oh, look at this novel, interesting thing that we found. But the reality is that, as we've identified, of course, with the replication project, the vast majority of these actually don't uphold to replication. And that means that they're not true. And in fact, about 80% of published research in sports and exercise science is research that has a significant novel or positive finding. And that is not possibly true on the basis of what we know today about the size of the effects that people are measuring. It's not possible for us to have this many positive findings, and combined with the size of the samples of the number of individuals using to test these things. So in other words, I said we weren't surprised at all by this replication finding, and they're really the two big reasons. That the size of the things that we're measuring are actually very small. Imagine in our study here on the effect of heat acclimation on something like running in heat in an endurance race. There would definitely be a marked improvement in your capacity to deal with heat. But overall, the effect on your performance is not going to be life-changing. It's relatively a small aspect of many different things coming together that might determine your ability to run something like UTMB. And if typically these studies are done with sample sizes of 8, 10, 12 people, it's also very unlikely that you'll actually successfully be able to measure this small thing unless you're engaging in practices that might increase the likelihood of this being statistically significant. Hopefully, I haven't convoluted that explanation. It makes sense.
And I mean, I understood it. The graphic I have in mind is kind of, it's quite popular now, of like someone trying to sell the secret of good life is the basics: sleep, good food, a bit of sport. And then the other one, no, the secret for a good life is these pills. And the line for the people of the pills is very long. And the line for the basics kind of it is non-existent, essentially, because people are after this heat intervention which gives you 20% better performance, not these many little things which make it so much better.
I think that's a really good analogy for really the way that people are consuming sports science these days, right? Which is they do want the quick fixes and the shortcuts and the new novel things and the best watches and the optimal shoes. And I've said so many times now that people are forgetting the fundamentals of sport, or that really what really matters is, instead of consuming these studies and working out whether I should be exercising at 75% or 78% of my max for 3 or 7 minutes, or with a minute recovery or 75 seconds recovery, remember that the principles are pretty universal, that the body just adapts to the specific demands imposed upon it in a pretty general way. So as long as you apply a general, very sport specific stress on a regular basis, you allow enough time for adaptation, you have a high quality of life outside of training, which means good sleep quality, good nutrition, low stress in other aspects of life, then you're going to probably get 95% of the benefits of training and your performance. You don't need all these small, subtle things that people are obsessed with today. But those boring truths, we talk about novelty and people want the clickbait and the sexy stuff. That's pretty boring to hear, right? People want to know, should I be taking beta aniline on
Yeah.
my ultra run? What's the latest thing that the ultra runners, the elite runners are using? That's what I want to be doing. And they often neglect the fundamentals here, I think.
Yeah. Do you think that, I mean, your study maybe covered just 25 studies, so you replicated 25 studies, which even there is not a big sample size. But do you think certain areas or of sports science are more prone to this sort of over exaggerated reporting, maybe? Or do you think all of them may suffer from similar things? So, for example, I don't know, something around training methods. So, too much zone two, or periodization model, or nutrition, or, you know, do you think they're all subject to the same problems, or some might be more prone to errors, to use that term, than others?
Yeah, another great question. Like, my professional answer is, well, we really don't know because we
Yeah.
haven't systematically examined this, right? It would take a huge amount of studies and a number of years to systematically go through each of the subdisciplines within sports and exercise science and evaluate whether some claims are more robust than others. We're certainly miles away from anything close to that. It doesn't mean I don't have my own opinions or my own experiences within these subdisciplines. So anecdotally, at least, I would say we would have strong concerns over the nutrition area of research. One, because there's a lot of invested interests, a lot of funding into nutritional claims and developments of new nutritional supplements, etc., that are probably highly at risk of bias and invested interest from other departments, etc. And then also anecdotally, we would see from looking at the dedicated strength and conditioning journals, it seems to be that some of the strength and conditioning research is of particularly low research quality to us. Now, again, professionally, I can't stand behind that. Empirically, we haven't got the data to support it. I very much think that in the strength and conditioning area, having come from working a lot in that area myself, is a lot of the people that are writing the research in S&C are very much applied practitioners. They're coaches, they're people that are out in the field that are working with the athletes in the gym, and less so the dedicated hardcore scientists that are doing the really high level methodological rigor and thinking and statistical analysis. Um, and both have merit. Like, I think sports science particularly suffers from this. You said, for example, that you came from IT, where you found it a little bit difficult sometimes to relate to the statistical stuff. But if you imagine that when you go and sign up for something like IT or engineering or accountancy, there's somewhat of an expectation that you're going to study numbers and maths and
Yeah.
do statistical analysis. So it's a part of the course of what you're identifying that you're going to study. But very often we find that people who want to study sports and exercise science don't identify that way. They see sport in the title and they think, I want to work with athletes and be a coach or a practitioner. And very few of them identify with someone who might spend their time in the lab, or the hardcore scientist who's crunching the numbers or doing the statistical analysis. And so I think one of the concerns around the low level of expertise in sports science probably comes from the fact that very few of our practitioners are ones who really identify as the nerdy scientists per se, the ones who really understand the philosophy of science and the statistical nuance of what they're doing. Um, and we could counteract this by encouraging more collaboration, people working with more experts. But in fact, they're increasingly hard to find within our discipline, we find as well. So it is definitely an interesting point, and I think one of the concerns is around the education of these specific aspects.
The way you have kind of phrased this problem is more, it seems to be a systematic issue. So it's not that there are individuals who are malicious or who desperately kind of want to find a specific result, but rather that maybe over time the process started to not be as rigorous. We started allowing things which we shouldn't have. Maybe the incentives are wrong. So where can we start maybe fixing it on an academic side, right? Like what are the things that we can start introducing within the process? I don't know where to kind of try to make this slightly better.
It's really difficult, right? Because we're so deep rooted in the way that we do things right now that it's actually very, very difficult to. I can make a lot of suggestions for how things can improve, but actually seeing them change, I imagine, is going to be a much longer process. And some of these things are already happening, and we've actually had some really good positive feedback from our work that has really incited changes. For example, Journal of Sports Sciences has made mandatory sample size justifications on the basis of some of our work, and of course some of their own work as well. So there are some things that we can do pretty quickly. We can change the way in which journals enforce standards of inquiry. That means be much more transparent, share your raw data, pre-register the studies before you ever conduct any analysis, very carefully justify the sample size that you need to measure these effects of interest, and that will make more robust claims in the long run. And in general, engage with the idea of falsification. And that is, in other words, we have to stop prioritizing only publishing the sexy, interesting, novel stuff and actually allocate more spaces in journals for non-significant findings or replication, etc. So these are all things that can improve. They're very slow to occur. Um, Unfortunately, again, until we remove the opportunity ladder from academia, I think we will always be working uphill here, because this rat race per se isn't just in the world of the researcher themselves, the person who's chasing this publication, but it's also in the journals as well. It's in their, we have unfortunately these ranking systems that exist for academic journals where they are trying to get higher and higher up this hierarchical order of journal quality, right? This index that we use to measure how many times people are reading or citing papers within different journals. And so it's highly competitive in market and environment. And we know that papers, there's some good empirical data that says that papers that are less replicable, that are more novel or sexy, are more likely to be cited. So people are more likely to read and to reference studies that are more interesting and more sexy. And so, unfortunately, we kind of propagate this system where, in order for these journals to keep getting higher and higher up this ranking, and therefore they'll make more money because journals will subscribe for access. Universities will subscribe to access to these journals, and people will pay for access more regularly. They have to engage in this kind of game of what's going to give us more clicks, what's going to give us more citations, and so they prioritize these novel and interesting findings. So ultimately, come back around to your question, the only real way that we can fix this problem is that we remove any financial incentives or any incentive structures from research altogether. But that's almost never
Mm.
going to happen.
Yeah, of course. Yeah. So you mentioned that some journals started to introduce some additional checks or change their processes based on your suggestions. What do you think has, or how has been the reception kind of from the wider audience um, with your work? So, like, I don't know if there were any colleagues that you ended up investigating, or like their studies, of course, not them. Um, I don't know, maybe you've gone to some conferences and you've noticed that people are happy or unhappy with it. Like, how has the atmosphere in the room kind of been?
Very mixed in general. Firstly, we've had a huge amount of avoidance. We kind of reported this in the study, and we also wrote a second paper, which is like reflections of the process and what we learned from doing this. And definitely, it was a very mixed audience. A lot of people just refused to engage with us whatsoever. Some people accused us of conducting a witch hunt, that we were directly out to try and falsify people's work. Some people directed us to read only other people's work. They would say, well, don't look at my studies, go and look at this person's studies because they definitely need their work investigated, as though this was some kind of directed attack on specific researchers. So in general, I would say we're trending towards it was a very immature response to the replication project in general. Of course, there was a spectrum. On the other side of things, we had very, very engaged and interesting parties, and people said, that this was badly needed. Another colleague of ours, a researcher, said when they heard about the problems, the project, it gave them goosebumps. They were that excited that something like this was actually happening in sports science. So, you get a wide range of responses to something like this. But in general, I'd say it was both non-existent. In other words, people just didn't want to engage with us whatsoever, and often quite negative in the way that people approach it. Also, you asked about how, maybe journals perceive, or the changes in journals as resulted in a change. And interesting, one of the things that occurred, not as a result of our work, but kind of simultaneously, is a couple of journals started to advertise for a new type of submission called registered reports. And to encourage pre-registration. Now, essentially, what a registered report is that you would have your study peer-reviewed before you ever collect your data. So for your listeners who may not be familiar, typically what would happen is that a researcher or a group of researchers would design the study, write up the justification, get ethical approval, collect the data, analyze the data, and then when they've written up the final paper, only then it would go to peer review. And we talked earlier about one of the issues here is that kind of under the bonnet approach, which is you don't really know then all the decisions or the changes that occurred through the process of finally submitting that paper to be peer reviewed. But a registered report, actually, you write up the justification and the methods, and you submit that for peer review, and then the peer reviewers will evaluate whether the study is of high methodological quality, and they will guarantee you, if you follow exactly as you have reported in this this registered report, we will guarantee that we publish your findings. It doesn't matter what you find. So whether it's a significant finding or a non-significant finding is irrelevant because your methods are very high quality. And so it's a very, very positive way of doing research and very transparent. And so a couple of journals, notably Journal of Sports Science again, and Journal of Science and Medicine and Football, both led by very, very good meta-scientists and leading figures, Grant Abden, Franco Impellizzeri, who are doing fantastic work in this area. They both encouraged and marketed, we now accept these registered reports. And in the 4 or 5 years that these have been available, both combined have only ever received one submission.
Wow.
So,
Wow.
again, it's a roundabout way of coming back to your question, which is how are people responding or leveling up and accepting this problem, and then bringing their research up to this level of statistical inquiry that we're looking for? And the answer is probably very poorly. So not only are we seeing almost a non-existent response from researchers who will very commonly say, no, we recognize there is an issue. We really need to improve the way that we're doing things. Empirically, we're not seeing those responses yet, at least. And where even people kind of play the game. So, there's a big encouragement now on researchers across all of the journals to try to have some sample size justification or statistical power analysis. And this is basically just a way of calculating your sample size requirement on the basis of the size of the effect that you're trying to measure, so that when you do make a statistical claim, you can be more confident whether this claim is true or not, basically. But what we're actually seeing, and we've systematically evaluated this, that even when people do claim that they've done this, when we compare studies that have a sample size calculation and those that don't, we're seeing no difference between the two whatsoever. And this tells us, because we know that the sample size and statistical power in our field is very low, that people are just playing the game. They're opportunistically kind of retrofitting these numbers into their study to make the peer reviewers think, oh, look, they've kind of done this power analysis and that's great. But actually, it's still very much suboptimal. So to answer your question, I think we're still very, very slow to see a response to the bigger picture and really see a large scale change in behavior.
Yeah, when you were discussing or describing this kind of pre-registration and like earlier review, I was like thinking, this could be good because, like, even from an incentive perspective, because you get kind of your peer review done earlier, so you kind of don't have to invest even more time on the analysis side. Like, this will get published as long as I just continue. But then on the other hand, it's like, okay, you're pulling your pants down in public, right? Like, this is what I'm doing, scrutinize even more what I'm doing, because again, you're not looking at the buffed up car, you're looking at the internals. And yeah, before you told me that they only got one each, I was like, maybe there would be some uptake, but the fact that they got one left me a bit. Yeah.
And,
Although I
and
understand it.
most people cite, when I've asked people about why they haven't engaged in this, they say it's just too time consuming, to write up all of this beforehand and really think about it. And actually, it's not, because you're right. You save a lot of time in the long run by doing this early on. And most people already have written up a lot of this when they seek ethical approval, for example. You need a high level of methodological detail to get ethical approval for a lot of these projects. So most of the work is already done. I think probably the most damning aspect for many people is that it somewhat ties their hands together, and many people haven't made the decision about how they want to analyze their data or what specific theory that they actually wanted to test. And in fact, we believe that many researchers are just collecting a lot of data very opportunistically and then retrospectively analyzing that and then saying, oh, this looks interesting, so let's write this up and say that this is what we wanted to investigate. And so you don't have that hand-tied aspect, right? You can kind of write it up in any flexibly way that you would like, and it's somewhat easier to do it in your own time and uh, and to flexibly create this product, this end product. So it's difficult to say why people aren't doing it more, but that's probably one of the reasons.
Yeah. Yeah, in my article, the example I gave is kind of like, let's say you wanted to see if running in a particular colored shirt is faster than another shirt color. And kind of the way I described it is you'd have 20 groups of people run in a different colored shirt. And then from those 20 groups, find the two poles and say, hey, red is better than orange, because those, but you do not show that you tested 18 other shirts, because between those it shows nothing, right? That's the opportunistic kind of approach that you described, if I understood it correctly.
Yeah, and this is called harking. This is developing a
Right.
hypothesis after your results are known. And it's something that's very difficult to determine. So we don't actually know if people are doing this because no one pre-registers their work. We don't really know that those hidden degrees of freedom or the decisions that researchers are making, and we don't know all the data that they chose not to disclose. So it could be very prevalent, or it could be not be very prevalent at all.
Yeah,
We don't know.
we don't know.
However, what we can do is some very intuitive analysis by looking at distributions of reported p-values, for example. And so we can actually see, because as you well know, and many of your listeners will know, that generally we use this binary system of decision making, which is if a p-value is less than 0.05, we say kind of thumbs up, we have data that might support our theory in the long run, or if it's above 0.05, we say there's not enough evidence here suggests that there is different than the null, right? So in other words, we can't conclude that there is any finding within this data. So this p-value threshold of 0.05 represents a critical point of this novelty or significance bias, right? If it's below
Mm.
0.05, people say, well, hey, let's celebrate, it's significant. And if it's below, people think, oh, this is boring and not novel and interesting. Remember, even though we've said that a non-significant finding is just as valuable, I want to know if something doesn't work just as much as I want to know that it does work, right? So actually, when we plot hundreds of p-values across published studies, you will see whether people are deliberately selecting only these significant findings, because what you will see is just inside that line of p 0.05, there is a rapid increase in the number of published p-values. And that would suggest, again, publication bias. But more alarmingly, actually, just outside of 0.05, the study findings that would have just been non significant, they should be just the same as the values that are very, very non significant. And what we found is that they almost don't exist. So not only are journals and researchers more likely to publish and submit these significant findings, but actually we have evidence that there is some form of p-hacking, that people are deliberately manipulating their data to push these p-values directly or just under the significance threshold.
Right.
And that's more concerning. That's how much we are trying to find these novel things and how much we believe that this is more likely to get published if that exists. And now you can see that all semblance of reality or truth goes out the window, because we can't trust anything if people are now manipulating their data.
Right. I, when you were talking about sample sizes, one question which kind of got to mind is, with the increase of like wearable technology, heart rate monitors and stuff like that, do you think that the wearable technologies and the distributed nature of athletes can help solve this sample size issue, right? That you maybe do some sort of studies where you incorporate a lot of remote people, like through, I don't know, some forms, or like essentially illicit signups through social media? Or do you think the quality will not be good? And of course, you can't do it for everything, but for those where you can um, kind of check or like outsource the methodology, is that something in your eyes valuable? Like, for example, when you look at the Strava year in sports, they always do their metrics based on the data they have. Of course, there's noise, but there's also like 1 million people in that study. So it's like, should we maybe try to go on the other side where we have bigger sample sizes, even if we um, pay a bit in accuracy?
Definitely, yep. So this big data or big science approach is definitely worthwhile, because you're right in talking about noise. Really, what you're trying to do is untangle signal from noise. That's the whole principle of this, what we call the frequentist model of scientific reasoning, and of course, when you use something like these wearable technologies or Strava or all these things where it's highly unreliable data, there's no standardization whatsoever in the way that people engage with or use these digital technologies and the way this data is sampled, you're going to have a lot of noise. And the way that you overcome noise is by increasing sample sizes. And eventually, if there is any signal, it will emerge from enough data. So I do think that when you're working with big data sets like Strava, like Garmin wearable technology, where they collect all their GPS data, I think you can extract some very meaningful signals from that data, because of the sheer size of the samples that you have. It's a very blunt instrument, and it's, again, you'll be able to answer some very simple questions, but some of the more nuanced things, like the effects of sodium bicarbonate on performance, or nutritional supplements, or heat acclimation, things like that now become much more difficult to do. So you can't use that big data approach, unfortunately. So here now we're inherently limited by small samples, because it's very difficult to test some of these things in a group of individuals, particularly in elite athletes, remember, where it's very difficult to get access to large bodies of them. But I do think, on that same basis, you talked about technology. We do live in a world that is now full of some remarkable technology that we can get much higher levels of collaboration. And I don't think we're using this well enough yet. So, for example, individual labs or individual research groups will say, well, we're limited in time. We work in academics. We've only got so much time we can allocate to research. We're very interested in ultra running science, but we can only recruit 15 people for this study. But it is possible now to do what's called a meta-synthesis approach, or a many labs approach, where you have a number of different collaborators in different labs all around the world, where they follow exactly the same methodology. They recruit the same amount of people as you, and now you meta-synthesize this data together into kind of one larger project. It was one of the big benefits or lessons from the many lab projects from psychology. So I think we now live in an era where I don't think we can keep saying, yeah, but in our lab it's very difficult, or we don't have the time or the resources to recruit people, when we should be working much more with collaborative groups around the world. And if COVID taught us nothing, it was that if people get together and collaborate on bigger research projects, that we can do this digitally with technology. And I would love to see this happen more in the future.
Yeah, that kind of multi-lab model was also something I was thinking about, because like you hypothetically could have a like a collaboration with the University of Salzburg, which is relatively close to me, and instead of just having 10 athletes or 10 subjects in Dublin, where you're based, you can maybe collaborate with Salzburg. They have 10 in Salzburg, 10 in Dublin, and then you have a 20-person study, still controlled. You can still do your bicarbonate with the exact same method, and then maybe um, the next time when Salzburg needs help on one of their research, then of course Dublin can help out. So what is the disincentive here? Like, is it because it's a lot of work not for your study? Is it because there is no value in big sample sizes? Like,
Um, just before I answer that question, to go back to one of the benefits, because you said this is a good idea. The whole process of this frequentist model of reasoning and using probability or p-values is, it was built on this idea of randomization by Fisher, who's one of the guys who came up with this concept of probability analysis, or frequentist analysis. And so essentially the idea is that if you collect enough random information, again, a signal will emerge from the noise. And not only do we have this issue with small sample sizes, but also with convenience sampling that happens, that people don't actually understand the value of true randomization, that we do need to randomly select participants or samples from a wide, diverse range of a population. We can't just say, I know 5 lads who run ultras, so I'm going to recruit them into my study, because now you're introducing inherent bias to location, training habits, environment, access to trails, all of these things which convenience sampling doesn't allow that randomization to occur. So what I wanted to point out is that the additional benefit of these multi-lab projects around the world is you incorporate more randomization, because you've now got a much more diverse sample set of individuals, not representing one part of the world or one training methodology. That means that it's a much more representative finding. And because one of the big issues with consuming science is people will often say, yeah, but that only applied because they were females between the age of 18 and 22 who were 68 kilos on average. It only applies to that very specific cohort of society. But this more diverse, representative, generalized sample size method of taking people from all around the world from different labs would allow us to make much better generalizations for whatever we find. It would be really valuable. So go back to your question. Why doesn't this happen more? I don't know. I think the main thing is time, because, again, one of the concerns with the academic model is that people are being put under increasing pressure to produce work, but given less allocation of time or resources to do so. Because, of course, mainly the financial model is that we have academics who work primarily in teaching or in education, and it's a bums in seats model. Okay, so universities all across the world, their primary revenue is to get as many students in to sit these programs as possible. So more and more resources and time allocation is being directed towards teaching, but yet there's still this recognized metric for university, which is, well, we still need to keep up this research profile and have X amount of postgraduates and number of publications per year, etc. So I think, unfortunately, there is a casualty of time here. We need to dedicate much more resources towards these bigger projects, which is probably not happening yet. And I think it will. I think we'll see paradigm shifts towards these type of models gradually. I still think that we're very much in the early years, the kind of somewhat immature years of collaborative networks in sports and exercise science, and we should see a lot of that improve, I think, in the near future.
Okay. Let's shift a bit now to the practical side, right? So when we kind of started nearing the start, you said it's also hard to understand what a high quality study is. Really, there are some things that you can use to understand, but we know, as you said so yourself, people don't even go to studies. They they go to social media, the clickbait, the so you have the problem to understand if you want to do a heat intervention for UTMB. The non-academic Joe, to use that terminology, what would you advise the non-academic Joe to do to understand what is worth his time, whether he should train more, train less, do a heat adaptation? Like,
Yeah, this is a question I've said on a few other podcasts I struggle to answer the most, because it's so difficult. I think we live in a time where it's never been harder to untangle fact from fiction when it comes to digesting information largely found online. Okay, because you're right, most people will not go to reading the articles and doing the in-depth literature review that this really requires, and instead they'll look for the quick answer. They'll go to their social media gurus. They'll look for these simple answers, and this means, of course, that we're getting a lot of noise and bro science that's being mingled in here with the reality of this. And at the same time, people will be heavily influenced by what the elite athletes are doing. That seems to be, most commonly, let's just see what the top athletes are doing and let's follow along whatever they're doing. So it seems that training seems to follow trends of what the other athletes are doing, and people follow like sheep, and occasionally you get someone who thinks for themselves a little bit outside the box, and there's a new way of doing something, and then everyone follows that one along. So this I find incredibly difficult to answer. What will work? Of course, there's on one side, you do need some level of evidence-based practice. But that's very time consuming. Really the way in which I approach this is to somewhat systematically. So again, if I'm non-academic Joe and I want to know what's the most optimal way of getting acclimatized to heat in UTMB, which will be a very real problem for me. It was before, it will be again. Okay. So the first thing I would do is I would, of course, go and something like Google Scholar, and I would start consuming a lot of articles, not just one. Don't, because if you go to Google and type in uh, heat acclimation in ultra runners, what's going to happen is, through the nature of the way in which all these search engines work and all digital media, it's going to push the more novel or interesting or more read articles to the top of that list. So the ones that you're going to see are, of course, going to be the ones which are, yes, this is an effective method of doing this because it's novel and it's sexy and it's significant and people want to read it and cite it. Now, that could represent the tip of the iceberg. And in fact, underneath that, on page 50 in Google Scholar, you might start finding the reality, which is we don't know. This is an ineffective protocol. This one didn't work, etc. So that's again the first rule I would give the lay consumer, which is no one study is proof of anything. And if you really want to start to digest the reality, you need to actually work your way through a lot of articles. And I've said on a few other podcasts that what I would have previously recommended is, well, you go to the gold standard of research, which is a meta-analysis or a systematic review. And essentially, for people who aren't aware, essentially what a meta-analysis or systematic review does is it does a very, very careful review of all of the published literature in this topic, let's say heat acclimation for ultra running. And then it will gather all of the relevant studies that have done an intervention, and it will publish the overall finding from all of these studies together. And we would have said, well, this saves you a lot of time because now you actually will see the overall signal from the noise here because all these studies are already combined together. But actually, we've also systematically investigated the meta-analysis in sports and exercise science, and we found that they are well below optimal. So we're now kind of at a point where we don't really trust the systematic reviews and meta-analysis either. And there's high risk of bias and very poor methodological decisions that have been made in a lot of these studies. And unfortunately, they suffer from the same significance filter because the vast majority of maybe the real findings, the non-significant stuff, never got published in the first place. And the issue with a meta-analysis or a systematic review is it can only evaluate what's there in the published literature. So you don't know what's in the black hole, what's not available. So I'm sorry, this is the one I really struggle with because I would love to give someone a real tangible way of trying to work this out. One thing I've considered, because obviously people are increasingly going towards social media to get their information. And of course, this is again just a clickbait market, right? What is more interesting or sexy or novel or alarmist? That seems to be the big headlines that get the clicks and get the likes and the follows. But I would be very much a fan of if we had some, you've got the thumbs up button or the heart button on social media, and that's kind of like, oh, this is cool content. But I'd really be a fan if we brought in a second button, which is only available to qualified individuals, which is like a content verification button. So like I don't know, a green tick, for example, where in fact people are now recruited around the world. So on Instagram, for example, you get your blue tick, which means you're an official registered person. We could have a green tick for people who are recognized as leading professionals in certain areas. And they are just encouraged, not necessarily, you'd never get this like a paid position, but they are encouraged to do content verification as they're scrolling. So if something does appear to fit with the body of knowledge, they can give a green tick, for example, and then we might have a much more verifiable body of research or body of social media content to ingest. But maybe that will never
Yeah,
happen.
I think YouTube have a slightly similar approach. There is a one particular quite famous doctor, and he's got like under all his videos, there's like this banner which says person is a registered doctor in the USA, something to kind of show the credentials that this person has. I also can see how that will become a big black hole because if this one single moderator, to call him that, starts saying that, hey, why are you blacklisting all my content and not that guy's? Yeah.
Yeah, I mean, I
One.
think if one thing is to be learned from this is that, a single human is at high risk of bias, no matter how well we understand
Mhm.
the philosophy of science. I mean, I'm susceptible to my own biases just like anybody else, even though I'd love to think that I can be a bit more objective about it than most. But it's not true. So I think it does need a level of peer review. I think that's a very important infrastructure that was created for science that could be created for social media, which is there needs to be a mass peer review of this digital content. Um, Now, again, we reach new problems here, which is the introduction of AI to the digestion of any kind of content, which is it's very difficult now to determine what's real and what's AI created, right? You see this with videos all over the internet now, which is very, very difficult to distinguish between the two. And this is, on one hand, a problem because now we've got an additional level of clickbait or this false idea of reality. But at the same time, I think it won't be too long before AI is intelligent enough that this level of peer review or this level of social media uh, scrutiny could be done by artificial intelligence very well. And we could actually start getting up and down ranking or content on the basis of how artificial intelligence that's very intelligently screened it and decided that it is fit for purpose or appropriate to be shared. So that might be a big positive of AI in the future, but we've yet to see.
Yeah, there is this. I don't know if you've ever used Consensus.
No.
It's a tool which is essentially an AI for scientific literature. Kind of, you can look through kind of scientific literature, and it's got this like consensus meter. So like you can ask it for a consensus, and if you do heat adaptation for ultra runners, whatever, it will take 20, 30. Again, you'd have to dig in and then to see the results and tell you, for example, 10 papers say that there's a positive effect, five say there is no effect, and five say there's actually a negative effect, or something like that. Again, the whole incentive structure comes into it. What are they looking to push? Is it the ones which always tell you yes? And it's only always as good as the base data. So, like, again, if no studies showing no effect are published, then consensus can't report that there's no effect. But I find it's better than going on Instagram or whatever social media and just taking the clickbait. At least it gets you closer to what I would think is the truth. So
Yeah, I think platforms like that are going to be incredibly useful in the future. And it also will be possible that one of the limitations that we have in screening or peer reviewing scientific articles for publication is that it kind of lives or die by the educational status of the peer reviewer. So the bar that you have to pass to be a scientifically published author is entirely determined by the peer reviewers that decide whether your work is good enough to be published or not. And I can tell you that that is a very hit or miss environment. Sometimes you can have outstanding peer reviewers who really know their stuff and very much spend the time and do their due diligence on screening your papers. But more often than not, I find today, and this is changing rapidly over the years, you get somebody who you can tell has not spent any time whatsoever reviewing this because clearly they haven't got enough time and they've been inundated with peer reviews and either they haven't given it the time or they simply don't have the expertise to very carefully peer review this piece of work. And so that means that probably over time we're also somewhat dumbing down academia and reducing the quality in what we publish because the process of peer review is probably getting worse. And it might well be possible that we'll also be able to have a third or fourth peer review, which is that AI tool, that very highly qualified, very, very diligent um, method of evaluating a lot of the things in the study that maybe the peer reviewers themselves couldn't do or were at risk of bias for evaluating. So I am somewhat optimistic. In general, I'm not very optimistic about AI, but I think actually for science, there might be some really, really good breakthroughs here that can really help us. Um, and it really depends on what direction it goes over the next few years.
right. Yeah. Okay. I have one final question because we're also kind of getting short on time. In all this, where do you see the figure of the coach? Because we started saying that a lot of the very early science, and I'm using that term very loosely, was done through observation. And while like a lot of the coaches actually work through observation, I have my athletes do X, maybe it's scientifically informed, maybe it's not, and I see results. And therefore, I'm going to apply X on the other 10, 15, 20 athletes I have for the next 5 years until something really sways me in another direction. On one hand, it's like, well, at least they did some experimentation, so they have some proof, I don't know, some validation to their idea, but it's also observation. Nobody tried on the same athlete another intervention, which could have made them even better. Like, we don't have that luxury. We never have that luxury. So, where do you see the coach, the figure of the coach? And maybe you can also add some of your experience transitioning into that ultra world, right? Like, how did you approach it? Or, yeah.
Yeah, it's a great applied question, and I think coaches are in a unique position right now, which is science, and not just sports science, but science as a general, is very slow moving. And so it's very, very common that what is happening today in practice, and not just elite athletes, but athletes of all levels under coaching programs, are doing stuff that might be quite a bit ahead of the science, for example. So that, some people argue that it takes upwards of 10 to 20 years for science to recognize what people are doing in any given time in society. So I think it is very much a process of using a combination of a number of practices or methods in your coaching to be an informed coach. And the first should be observation. What is the huge body of athletes doing, in particular, what is in general elite athletes doing that appear to be consistent? What are the foundations of appropriate training methodologies? And I would use that as kind of the foundation of the way that I would coach. I would first establish the non-negotiable principles, the things which are absolutely essential in these athletes. That is things like careful periodization, adequate load progression, things that we all know but are somewhat boring today because they're so well established that no one talks about them, right? But the absolute fundamentals. And from that point, I would then very carefully sample some of the additional practices in a kind of trial and error fashion. So if I see an athlete like Tom Evans, who now is doing downhill running, heavily weighted. I know you had his coach on here and had a fantastic discussion about this. What I wouldn't do is say, oh, look, that's what Tom Evans did and he won UTMB. I'm now going to get all my athletes to throw on that weighted vest and we're going to start doing the same work. I would instead think, how can I very cautiously introduce this and see if it works for some of my athletes? But be cautious enough that I can regress if I feel like it's too much. So take that, again, you have foundations that are non-negotiable, and then you sample some additional practices, but you don't go all in on the basis of what people are doing. So I think taking a very sensible approach to training is really the way forward. And you'll see that most of the good coaches today, they're just down to earth people who understand that there's no shortcuts here. There's no, they're not turning over every new stone and designing every new way of training. They're just nailing the foundations, the basic principles, and then keeping up to date with emerging trends at the same time. For myself, I probably followed similar principles for this transition to ultra running. A lot of it was probably trial and error as well, as you can imagine, coming from track and this totally different world. So it was a combination of observation, again, watching what other people are doing, and then of course learning from my own sports science background. But a couple of the big things for me that really stood out is that ultra running is a game of logistics, and so there's so much more in this and around the preparation and the management of yourself throughout these extended periods, which is entirely different than running a 800, 1500, 5K, 10K, even up to marathon, where it's almost a very straightforward pursuit. You just got to get from A to B as quickly as you can with minimal concerns in the meantime, bar holding pace. And so the big lessons for me in ultra running really came down to individual diligence. In you have to be so regimented in staying on your nutrition plan, on keeping moving, on managing your pace, on all these things. And it was definitely trial and error for me to start to get some of them right, I think.
Yeah. Yeah. And sometimes we have this discussion with some friends like, what is harder, a 100-meter or an ultra? They always say, like, I don't think the question of what is harder is the right one. I just think that like by virtue of time, by virtue of the fact that one of them can take 24 plus hours, you just need to take care of a lot more things. So, for example, in 24 hours, you'll be happy, you'll be sad, you'll be sleepy, you'll be frustrated. Now, all those, but within a context of a race. Within the 10, 11 seconds of 100 meters, yes, it's hard. Yes, you need to have a fast reaction time and get off the blocks. So for me, it's just a different proposition. and almost like the I don't want to say the physical side doesn't matter. Of course, you have to train. There are no shortcuts for that, but you also have to make sure that everything else is also catered for.
Yeah, I think less of the in something like 100 or track race, it's very much about the prep and the lead in, and there's only so much you can control within the race. Whereas I think when you get up to ultra endurance running, it's somewhat switched in that most of what you control actually happens within the time period that you're racing. And yes, the preparation is absolutely essential, and the conditioning and the time spent on feet, etc. But it's probably less of a determining factor of performance than how well you manage the time in which you're moving for whatever that duration is. And I think in my experience, the longer that goes, the more that those logistics and the ups and downs and the emotional roller coasters, they become much more the determining factors, don't they? And so exposure to that is really important.
Okay, I think we're basically out of time. I will leave the last word for you. Um, where can people find you if people want to look at your research, or maybe in the future if you will conduct one of this cohort study where you ask people to submit their Strava data or something like that? Where can people find you, contact you, or something like that?
Oh, well, I'm actually not very good on any media, unfortunately, so I don't have necessarily a handle in which people can find me. We have a website, ssreplicationcenter.com, where you'll find most of the information about what we've discussed here. Right now, we don't have any plans to start any big replication study again. We're at a point where we kind of feel like we know that there is a significant concern around the way that we're doing research, and all of my focus, and indeed the full research team, is on improving practice in the future. So we want to now dedicate our efforts to making things better, as opposed to just telling people that things aren't very good. I don't think that's as productive. But I would say that I'm always happy to help people, whether that's coaches or scientists or people that are trying to wade through this tangled mess of misinformation and problematic process in the scientific method. Just reach out to us. My email is on the website, and any of us are always happy to help, and that's probably the best place to find us.
Perfect. Thanks a lot, Joe. Thanks for your time, and I hope the listeners learned something from this conversation.
Thanks so much for having me.